AP Calculus AB, evaluating a definite integral. So here we have this integral that we want to evaluate from 1 to 4 of 3 square roots of x dx. So first thing I'm going to do is I'm going to go ahead and rewrite this into a form that's easier to integrate. So I'm just going to say that this is the equivalent of the definite integral 1 to 4 of 3 times x to the 1/2 power dx. And remember that x to the 1/2 power is the same as the square root of x. So because we know how we're going to integrate this, so I'm going to go ahead and integrate now. I'm going to go ahead and integrate. I could pull that 3 out, but I'm not going to be honest with you. Remember that when we integrate, we increment the exponent by 1. So 1/2 plus 1 is 3/2, isn't it? So we get x to the 3/2. And whatever we get here for our exponential value, we also get that as the denominator of our fraction here. And then I'm going to use a little bit of notation that says that I intend to evaluate this from 1 to 4. I'm going to clean this thing up. Clean this thing up a little bit. Bring this thing up as 2/3, so it would be 2/3 times 3x to the 3/2. Isn't that right? This 3 and this 3 cancel. So now we get 2x to the 3/2. Remember, as evaluated from 1 to 4. Now I'm going to tell my AP reader that I intend to use the fundamental theorem of calculus. I might even say that this is FTC up here. And so I'm going to say that I am going to be evaluating f of 4 minus f of 1. So f of 4 would be 2 times 4 to the 3/2 power minus 2 times 1 to the 3/2 power. I'm going to go ahead and do a little bit of arithmetic here. The way I would probably do this is I would cube this 4 to get 64. The square root of 64 is 8. 2 times 8 is 16. Hope you followed that little bit of math there. 1 cubed is 1. Square root of 1 is still 1. Negative 2 times, I put it as 18, sorry, 16 is still 2. And 16 minus 2 is equal to 14. All right? So that's what my notes would look like. I hope the video was helpful. If you haven't already subscribed, please do, and your comments are always welcome. Thanks a lot, you guys.